The proper selection and installation of HVAC equipment is essential to maintaining comfort in a home.
We should think of the refrigeration system as really being, the heating system, to be the heart of the house. Okay, this is what is going to make things work. This is what makes it tick. This is what keeps heat flowing in the winter, cool air flowing in the summer.
In order to install equipment properly, it takes training and the correct tools. It is a precision profession. As with other sciences, there is no room for guesswork.
You wouldn't want to go to the doctor and have him just kind of place his hand on your chest and say, oh, it looks like your heart's beating fine. You'd want him to be using a stethoscope. You'd want him to be using EKGs. You want to make sure that he has quantified, he knows exactly what's going on. And this is what we need to be doing with our HVAC equipment.
Because training is essential for a well-installed system, we're going to look at some key problem areas and show you proper techniques. We'll look at proper sizing of equipment, setting the air handler, sealing the air handler and plenum connection, measuring airflow, setting the condensate line, setting the outdoor unit, piping installation, and charging the system. The improper sizing of HVAC equipment is one of the most common problems in the design of HVAC systems. Studies show on average, systems are oversized by as much as 55%. And that oversizing can reduce the actual SEER by 10% or more.
It can be oversized by 1 ton to 2 tons and sometimes even more. Sometimes contractors think that bigger is better, and it's not. We want HVAC equipment to be right-sized. Right-sized equipment will provide comfort and energy efficiency for the homeowner, and the money we save we can use for other measures in the house.
Actually, bigger is worse. Oversized units can cause a number of comfort and service problems.
What happens when we oversize our equipment is that we have shorter run times and what we call short cycling. And in our heat pumps and our air conditioners, the system maximizes, basically gets its maximum efficiency after it has run for a certain amount of time. Depending on the piece of equipment, that could be 10 or 15 minutes before it gets to its steady state of operation. And if we are running, or if we're short cycling, in other words, the system isn't running long enough, the system never reaches that steady state operating capacity. And that is where the efficiency comes in. So you have the equipment, it's starting, it's stopping, it's starting, it's stopping. It never quite gets to its maximum efficiency.
The oversizing causes the system not to run very much, and so it doesn't dehumidify. It can cool the house fine, but it doesn't get the dehumidification that it needs in order for people to be really comfortable.
There are a number of ways you can properly size HVAC equipment. The Air Conditioning Contractors of America, ACA, publish a series of manuals that can help you calculate heating and cooling loads and design the entire HVAC system. Several computer programs based on ACA Manual J guidelines are now available. These programs calculate loads based on a number of factors: orientation to the sun, climate, glazing, exposed footage, and much more. Loads are based on science and research, not rules of thumb. Estimates in HVAC sizing often result in oversized, inefficient equipment. Whether you are working in an attic or a crawl space, it is important to make sure the air handler is installed properly. This contractor prefers hanging the unit rather than sitting it on concrete blocks. This not only prevents moisture from corroding the metal exterior, but it can also be a more secure way of setting the equipment. He places 2x4s on the metal frame to elevate the unit. This is to allow more working room for service technicians in the future. He makes the plenum connection by installing a flex connector. This will help absorb vibrations in the system.
We don't connect the air handle directly to the metal supply trunk. We use a flexible connector, which is keep any movement or vibration from the air handle passing to that metal deck and going to the floor of the house.
Leveling the unit is also extremely important to the operation of the equipment. It helps to ensure the condensation lines drain away from the unit. Check your levels at all points to make sure the unit is level and secure. Finally, this contractor installs rubber pads on the bottom of the unit to help absorb vibrations.
Okay, put this side here first.
When making the plenum connection to the air handler, taking extra care to seal this connection is extremely important.
Okay, push in a little bit more.
It is here that much of the air leakage can take place. Proper technique starts from the moment the connection is made. You can see these small gaps at the corners can be potential sources of air leaks. This contractor first seals these small gaps with a UL 181 foil tape. He then uses a fiberglass mesh tape around the entire connection. Finally, he paints this surface with mastic. After this connection is sealed, it's important to secure the insulation. This contractor holds the insulation in place with a UL 181 foil tape.
About right there. Squish it in real good there.
He takes the door of the air handler off, both to protect it and to make sure the seal isn't broken when opening this door in the future. As before, he uses fiberglass mesh tape around the entire connection and then seals it with mastic. Measuring airflow is one of the most important steps you can take as you start up a new system. If the wrong amount of air is moving through the unit, measured as cubic feet per minute or CFM, the system will not operate properly. First, you need to check the low voltage wiring. Improper wiring can cause big problems later.
One of the important things in wiring low voltage is to twist the wire nuts, or anytime you're going to use a wire nut, is to twist the wires before you put the wire nut on. Wire nut is used just for cover for the wire. The actual connection is made through the twisting of the wires. You just put the wire nut on, you're going to have a loose connection, and that could cause your relays and contactors to burn up.
Measure the voltage and amperage at the disconnect. The readings you get here will be important in measuring airflow. A good quality meter is an important tool for any HVAC technician. Accurate and reliable measurements are critical to a quality job. Check your meter and write down the number you get after each measurement. Next, you'll need to get the temperature differential measurements, or TD. With heat pumps, you'll first need to turn the thermostat to emergency heat and set the temperature to 90 degrees Fahrenheit. Allow the system to run for several minutes to achieve maximum operating temperature. Next, drill a hole in the supply ductwork. Be sure to locate your hole so that your temperature probe is out of view of the heater elements. The radiant heat from the elements will give you a false reading. You want to measure the air temperature on the supply side. Now, you're ready to insert the probe and get your reading.
What you want to do is keep the probe as close to the center of the ductwork as you can. Although putting it in the center this way, it's going to have a tendency to drag the bottom, and you could get some static pressure there that could give you some false readings. Normally what I'll do, take a piece of Quest pipe and cut it about the middle of the ductwork. Got a little toy magnet on it. We'll take the temperature probe and just barely push it out the back side. And that's going to stay pretty close to the middle. It's not going to drag the bottom. It should give you the most accurate reading.
Follow the same procedure on the return side, drilling a hole in the return plenum. Once you've obtained your supply and return air temperature measurements, seal the holes with UL 181 foil tape. Now you're ready to calculate the CFM to see if your unit is operating properly. First, multiply the amperage reading by the voltage reading. This equation will give you your wattage. Multiply the wattage by 3.413 to determine your total BTUs. Next, subtract the return temperature from the supply temperature. This gives you your temperature differential, or TD. To calculate CFM, take the number of BTUs and divide it by the TDs multiplied by 1.08. For heat pumps, the number you get should be within 5% of 400 CFMs per ton of cooling, or the manufacturer's specifications for the particular equipment.
If you have too much CFM, what you would like to do is slow the fan speed down by dropping to a lower speed tap, or if it's not enough CFM, you would increase the speed by going to a higher speed. If you do have too much airflow and you cannot drop it any lower, what you'd have to do is put some type of damper over the squirrel cage fan inside to slow it down even more, to get a more accurate reading.
Installing condensation lines is another important job. Removing moisture from the indoor coil is not only important, it can affect indoor air quality and equipment durability. When installing the line, remember water runs downhill, so it's important to have enough slope on the line to ensure proper flow. Secure the line along the way to prevent sags in the line as it ages. And finally, install one trap. Any more than that will prevent the system from doing its job. When setting the outdoor unit, placement is important. Compressors can be noisy, so try to locate it away from bedroom windows or other areas where sound could cause problems. The equipment should be set on a level pad, away from vegetation and other obstructions. Check your local building codes for specific requirements in your area. When installing the refrigerant lines in a unit, there are a number of precautions to take. First, it is important to keep the lines clean of debris. Moisture, dirt, even sawdust can create problems and even destroy valuable components such as a compressor. And second, minimize elbows and sharp turns. They can impact system capacity and efficiency. Remember, the only thing that should ever be in refrigerant lines is refrigerant or nitrogen. Before brazing, clean the end of the pipe with an abrasive cloth. Check your tanks to make sure you have correct amount of pressure. Nitrogen is recommended to minimize carbon buildup inside the solder joints. If your flame is not hot enough, you will not be able to braze the line properly.
If it flows well, generally speaking, that's an indication that the rod is flowing smoothly. If it's going on kind of bumpy and rough, well then you may want to check your temperature and make sure you've got the right amount of heat on the joint.
Experts recommend using a solder with a high silver content, 15% at the minimum for copper-to-copper connections, and 45% for copper-to-steel connections. The better the solder is, the less likely it is that impurities will find their way into the lines. Finally, once the refrigerant lines have been installed, you'll need to pressure test to check for leaks. This is done by pulling a vacuum on the line using a vacuum pump and a micron gauge.
The problem that we have going on out in the field right now is that very few contractors own a micron gauge. And so they can't measure how well their vacuum pump is performing. All they know is that it is pulling refrigerant out of the system, but they don't know how well it pulled out. They think it pulled enough or well enough. But we know that there's significant differences in a vacuum that's being pulled at, let's say, 150 microns versus one at 500 or 750 or 800 microns. And many contractors don't even know whether their vacuum pump is even doing the job that it's supposed to.
When pulling a vacuum, your micron gauge should reflect a reading of at least 500. If not, you'll need to check the lines for a leak and repair it prior to charging. The improper charging of units is another common error that causes costly comfort problems. Research shows that more than 2/3 of the units in the field are improperly charged. Condensing units come pre-charged from the factory. Most specify a specific line length. Check the manufacturer's specifications and then measure the line to see if it meets the requirements of the unit.
Total line length of this unit, inside and out, come out to be 14 feet 6 inches. Manufacturer says that 15 feet It's a perfect charge, so this one right here we would not have to add or remove any refrigerant. If we were to add or remove refrigerant, definitely recommend you using a computer charge and measure it to the closest ½ ounce. It's extremely critical that your system is charged to the ½ ounce. A variance in just a few ounces can mean a decrease in your efficiency and an increase in your power bill.
Once you've checked the line set, you'll need to start the unit to get the other measurements you'll need. To get the subcooling or superheat temperatures, insert the probe of a digital thermometer into the insulating wrap of the liquid line or the suction line. Be sure it touches the line itself.
A digital thermometer is really the only way to check the suction and liquid line. If you check it the beer can cold method by putting your hand on the line, you get a totally inaccurate reading.
Check the pressure gauges and measure your amperage to make sure all the components are working properly. Finally, be sure to get a mega reading. This checks the integrity of the windings of the compressor and can provide important baseline information for future service technicians. Be sure to leave a record of the mega reading in a place that it can be easily noted. As we wrap up, let's have a quick review. When sizing equipment, use ACA Manual J guidelines. Be careful not to oversize equipment. When setting the air handler, make sure the unit is level and vibrations can be absorbed. When making the plenum connection to the air handler, seal all gaps with mastic and fiberglass mesh tape. Check the CFM or airflow on the system. Calculate the BTUs and temperature differential to get the CFM per ton. Condensate lines should have proper slope, be properly secured, and have only one trap. When setting outdoor units, place where noise won't be a problem. Make sure the pad is level and there are no obstructions. When installing refrigerant lines, make sure the line is clean of debris, the tank pressure is adequate, and the solder has at least 15% silver content. Check for leaks in the line by pulling a vacuum of at least 500 using a micron gauge and vacuum pump. When charging the unit, be sure to check the manufacturer's specifications and measure the line set. Check the subcooling or superheat temperature, pressure, and amperage. Finally, get a mega reading and leave it for future service technicians. The work you do as an HVAC technician has always been important. After all, a house is only as comfortable as its HVAC system. Now you can become an even more important part of the building process. You can build comfort for years to come.